No, sir.
So we will study the roots of equation by using numerical methods, and we were studying the bisection method, and we saw the methodology, how to find the solution using, or how to find the root of equation by using bisection method. Today, we will go through a numerical or example, and it will be more clear when we solve one example with you by using bisection method. So we have, let us say, the example is find the root of equation using bisection method with accuracy of 0.01. Okay, and the function given is f of x is equal to cos x minus 1.3 into x. That is the function given. So we have to find the root of equation with an accuracy of 0.01. So taking initial guesses as x1 equal to 0 and x2 is equal to 1. So that are the initial guesses we are assuming. X1 is equal to 0 and x2 is equal to 1. Now, in the step 1, the condition is, what is the condition to check whether our initial guesses are right or wrong? Okay, whatever initial guesses we have assumed, we have to check whether that initial guesses are right or wrong. So the condition is y1 into y2 should be less than 0. That is, the signs of y1 and y2 should be different. So let us calculate y1. y1 is equal to f of x1 minus, f of x1, that is equal to, so what is the function? Cos x minus 1.3 into x. So put value of x1 is equal to 0 in that function. That is equal to cos of 0 minus 1.3 into 0. Now 1.3 into 0 is equal to 0 and cos of 0 is equal to 1. So f of x1 is equal to y1 is equal to 1. That is positive. We got it as positive. Now y2 is equal to f of x2 is equal to, put x2 value in that function. Okay. So putting x2 is equal to 1 in this function, we get y2 is equal to minus 0.76. Okay. Now, one is positive, another is negative. Y1 is positive, y2 is negative. So product will be negative, right? So that is less than 0. So if the signs, yes.
So x1 is 0 and x2 is 1 is considered, but yes, I have considered x1 is equal to 1 and x2 is equal to something values.
Yeah, you can consider anything. That is fine. Like, okay. But what will happen, like, if you consider another case, okay, in the, you consider x1 is equal to 1 and x2 is equal to 2, let us say, okay. And if you solve for y1, then you will get some value, okay, and for y2 you will get some value, and let us say in that case you will get both positive or both negative. Okay, y1 and y2 both negative or both positive. If that is the condition, then our initial guesses are wrong. Okay, so we have to change our initial guess. Okay, then if that is the case, that y1 and y2 both have same sign. Let us say if here the sign was, let us say if the sign was positive here, y2 was positive, then in that case we have to again take x1 and x2 values. Then we will assume some another values. X1 is equal to 1, x2 is equal to 2, something like that. Okay, and then again we will check what is y1 and y2, and until we have different sign for y1 and y2, we will calculate it. Okay, Understood?
Yes, sir.
Okay. So now we have in the first step itself, we got one positive, one negative. Okay. So our initial guesses are right. Now, so in iteration, so what is the root? What bisection method says? That is the mid value of x1 and x2. Mid value is x1 plus x2 divided by 2. So 0 plus 1 divided by 2 is equal to 0.5. So that is the root for the first iteration, iteration 1. Okay. Now we will calculate y3 for x3 value. So y3 is equal to put value of x3 in that function. Okay. Cos of 0.5 minus 1.3 into 0.5. So we got 0.22759. What is this? This is positive, right? Y3 we got
Yes, sir.
positive. Yeah. So Y3 we have positive. So if Y3 is positive, so we have to replace earlier positive, right? Now we have Y3 as positive. So we should replace earlier positive. What is earlier positive? Earlier positive was
Y1.
Y1. Okay. Earlier positive was Y1. Y1 we were having positive. So
Positive
in
value.
yeah, so now we will replace y1 by this new y3, okay, because they have same sign. So in each iteration we should have different sign. So y3 we will put instead of y1. So y1 is equal to new y3, that is equal to 0.22759, and instead of x1 we will have x3. So initial x1 was 0, now new x1 is x3 is equal to 0.5. Okay. And x2 will be
Okay, sir.
same. X2 will be same. Okay. So now in that we will also check accuracy. Accuracy will be x2 minus x1. Okay. That is equal to 1 minus 0.5. That is equal to 0.5, which is greater than 0.0501. Okay. So in this step, we have not achieved our accuracy. So we will go for the next iteration. Okay, this is iteration 1. In the next iteration, we will repeat this step, step 2, step 3, step 4. Okay, so we will be doing the same. Okay, now we will again calculate x3. x3 will be x1 plus x2 divided by 2. So now what is x1? 0.5 from this iteration, right? We have x1 is equal to 0.5, x2 is equal to 1. Okay, so we will calculate x3, new x3, okay, in iteration 2. So x1 plus x2 divided by 2 is equal to 0.5 plus 1 divided by 2 is equal to x3. Now we got x3. Okay, now we have to calculate again y3. We will put value of x3 in the function and we get x3 as minus 0.2433. Okay, that we got as negative. Okay, now we got y3 as negative. So what we will do? What we should do?
Y1 is negative, means Y1 is equal to Y3 in first equation.
No. Whatever value has having negative in the earlier iteration, that we will replace, right?
Yes, sir.
Yeah.
Okay.
So here y3 is negative. So we will
Then
replace
Y2 is
y2.
Y2.
Yes, we will replace y2 because it was having negative here, right? Here it was having
Okay.
negative. Okay. Now we will replace y2. So y2 is replaced by y3, that is equal to minus 0.2433. And in the similar way, x2 will be replaced by x3. Okay. So now new x2 is 0.75. Right? And x1 will be same. Okay. And we will calculate the accuracy. Accuracy will be x2 minus x1. So that is equal to 0.75 minus 0.5. That is equal to 0.25. That is again greater than 0.01. So again, we have to go for next iteration. So in the next iteration, we will again calculate x3. Okay. In a similar way. So we will keep doing this, okay, until we get our accuracy greater than accuracy less than 0.01. So in iteration,
0.01.
yes, we will do the same step. Okay, in each iteration. Okay, in second iteration, we saw how we replaced x2. In third iteration, we will have negative value. So we will replace
Replace by
y2.
y2.
Yeah, y2. Then x2 will be replaced. Okay. In fourth iteration, we have positive value. So y1 will be replaced, right? X1 will be replaced by x3. So we will be doing the same steps until we get the accuracy less than 0.01. Okay. So here in iteration 6, we get accuracy of 0.0156. Okay. Here we get accuracy of 0.0156, which is just nearer to 0.01. So by that, but we understand in the next iteration, we are going to reach the accuracy level of 0.01. Okay. So we will directly calculate, we will not find the y3 and all this value. We will directly, after achieving just nearer value, we will directly calculate x3 value. x3 is 0.6015. So we will calculate accuracy that is less than 0.01, 0.0767. Yeah, 0.0078 is less than 0.01. So now our root is 0.6015. That is our root of the equation. So that is our final answer. Now we will formulate or we will put all these results in tabular form. Okay, that will be more clear. Okay. So now in the first iteration, we had x1 equal to 0, x2 is equal to 1. And x3 we calculated as x1 plus x2 divided by 2. That was mean. Okay.
नाही 2 दिवसांनी या म्हणे दादा नाही बघ म्हटलं तिथं थांबू म्हटलं आम्ही मग
Okay. Now.
Okay, sir.
Yeah. So x1, x2, x3 we will calculate. y1 is positive, y2 is negative, and now we calculated y3 that is positive. So what we will do, we will replace whatever earlier positive, right? So y1 we will replace. Okay. So in the next iteration, instead of y1 we will have this y3 value. That's why I have made the same color for this. Okay. And this x3 will come in place of x1, right?
Yes.
Okay. So now in the next iteration we have x1 as this x3. Now again we will calculate x3. That is x1 plus x2 divided by 2. That is 0.75. Again we will calculate y3 value and we get y3 as negative. Now we have y3 negative. So what we will replace? This y2, right? This y2 we will replace. Okay. Now this y2 means like x2 also we need to replace. Okay. So we will put this x3 in place of x2 in the next iteration, right? In the next iteration, our x2 will become x3. So in this way, we have to formulate this table until we get this accuracy of less than 0.01. So is it clear to all of you? Example is clear?
Yes, sir.
Anyone having any doubt?
No, sir.
You can practice this example. I will share this PPT with you and you can also go through this video and it will be more clear once you practice. Okay.
Okay, sir.
So you can put in chat whether everything is